Hello there, my name's Vince from My Mate Vince, and in this video today we're going to try to fix up 3 different items. So get yourself a nice drink, put your feet up, relax, let's spend the next hour trying to fix stuff. I'm looking and my hair is perfectly camouflaged with the picture behind, isn't it? Let's get started.
Deary me.
So this is the first item here, and I am with my brother Paul. I am round his house and this is his Henry vacuum cleaner. He was using it and then he turned it off, but it was still plugged in at the wall. He came back to it and smoke was billowing out of him. Henry was on fire. Let's see if he can be fixed. Now this Henry has been around for quite some time now. My brother's just informed me he's 25 years old. And if you have a look, you can age a Henry by the serial number on it. So if we zoom in here, you will see 00. So that denotes the year it was made. So this is the year 2000. So this is now 25 years old. If you look at this one here, this is one that I previously did in the video. And this one here is 05. So this is 2005. So this particular one is only 20 years old. This is still working fine after the contacts were replaced on top. So let's go on to the faulty one here and see why he's smoking so bad. Does he have a burnt out motor? I think maybe he does. Let's open it up and check it out. So we're going to take him apart. You can see that the switch here is all blackened. That was from the smoke that was pouring out of him. So let's we're going to undo some screws at the bottom here and see what lurks inside. Now just to protect the floor, we're just going to put this underneath it. Right, so there's loads of Phillips screws around here. Actually, it can't be a burnt out motor because it was off here. So it can't be a burnt motor, can it? Oh, I can smell it. Yeah, it smells really burnt. Ooh. Well, first of all, the contacts here are fine. Yeah, absolutely stinks. It smells sweet. Look at that in there. Can you see it's all blackened in here? Have a look here. You can see that we have the switch contacts. And we've got 4 contacts on the switch. And look at the mess of that. So I think we should pop the switch out. That looks like a capacitor or something. But that has exploded. You can actually see the cap seems to have come off, and it's swelled up everywhere. So see what we'll do. Let's get the multimeter on these switches here. See what they're doing. Maybe this cap is still shorted now. Mind you, we're just going to be measuring the motor, aren't we? I think we need to take all this out and get a bit of a wet wipe, give it a clean, so at least we can take a picture so we know what wires go where. Now to give ourselves a bit more room, and just in case the burning's gone more in, because you can see that there's been one hell of a fire here, we're just going to take this off as well. So we're going to undo the screw here, here and here, and then we can give everything a clean up and see what we're left with. Right, so taking this off here, undone the screws, it hasn't really helped because, of course, it's connected to the motor. What's interesting is it does look like there's some kind of thermal fuse or something here. So we have 2 wires going off to the switch area. So I think what we're going to do is we're just going to give everything a bit of a clean up, because you can see even by doing that how black everything is, and all around here is all horribly burnt. But I think what we're going to do is probably screw that back on, and then if you lift up this bit here, it gives you access to take the switch out, and then we can pull them out and we can give all the cables a nice good clean. So we're just going to give everything a bit of a clean up, make it nicer to work on, and then we can work out what that item is there. This bit down here is absolutely filthy, and the thing is, it looks more like kind of grease. It seems to have a bit of a green colour, but I'm just wondering if it's the electrolyte or whatever that's in these things here, these capacitors, because these look like the safety ones that you get on different things. So we're going to Google it to see if spares are available. But if I go across here, it really is absolutely filthy, and it feels like it's got grains of stuff in it, like it feels like sand. and it's nowhere else, so I presume it's to do with the capacitor. And it's sticky as well. Like there, I can feel that there's loads of bits of grains, which I think is the inside of the capacitor. I've got the multimeter on continuity. It is in the off position, so let's go here and here. So there's nothing there. Let's turn it on. Now we've got it, so we should have it here as well. And turn it off. Nothing, so that's fine. And if it's off across the cap, is nothing. So right now the cap has completely burnt itself out. Yeah, that's 0.6 megohms. Right, okay. I'm going to take a picture of this so we know what's what, and then I've got to Google to see if you can actually get these and to find out what it is, because I can't read any markings on it because it's just exploded. So I've taken some pictures now, so I'm just going to unplug this. Now these are ones that you just pull off, there's no tab to pull on them. And this is the broken one here, still really sticky. And now I'm going to give the spade connections here a nice good clean, and then we'll look up to find out what this is. So it looks like originally these were crimped onto here. Right, I'm going to have a look at Google now and type in Henry burnt component by switch, and let's see what comes up. Now I've just put into Google Henry burnt component by switch, and there's loads of info about it. On piston heads, vacuum cleaner with resistor and capacitor paralleled across. Looking at fixing a vacuum cleaner which generated a lot of smoke. Looks like a bulged capacitor has burnt out. My Henry burnt out vacuum lands, and it says, oh yes, I opened it up and it isn't the motor, it's the suppressor in between the switch and the power socket that's all burnt up. So clearly it's a common problem. And sure enough, you can get them on eBay. Look at this one here, Henry Hetty, which is just the pink equivalent, suppressor capacitor, pneumatic vacuum cable reel. And look, it says, and a discharge resistor. So you can't see that on that mess up there. But look here, there's a discharge resistor underneath it as well. So I'm thinking that the capacitor is to stop maybe interference going back and affecting things in your house. So going back onto the power network in your house, and the resistor must be to discharge the capacitor, so if you were to handle the plug, maybe you wouldn't get a shock if you went across the prongs with your hands. But correct me if I'm wrong down in the comments down below. So we're going to order up one of these, and hopefully it'll be just a case of taking out the old one, soldering in the new one, and then Henry should be working again, maybe for another 25 years.
A little while later.
We are back again, and the eBay part has arrived. You can see there we have the capacitor with the resistor across it. So it says M310 volts, that must be 310 volts, and then it says X2, so is it an X2 capacitor? We have here 220N, so would it be 220 nanofarad? And then we have the resistor there as well. I haven't looked up what resistance that is. Let's, in fact, we could measure that with our meter, couldn't we? And it's coming up with 0.635 megohms, so it's 635,000 ohms. I don't know whether it's getting a reading from the capacitor there as well, but yeah, that's what it is. Okay, so what we're going to do is let's chop this one out. So on this one, oh, I can see the resistor underneath this one now. So originally this was twisted round with the resistor and the legs here, and it was crimped onto here. I'm going to be using my grinding pen to get a nice clean surface, and then I'm going to be soldering it on. You can see that the resistor is there. Now, I don't think it makes a difference which way the capacitor goes around because I can't see any markings on it. Let's just give this a little bit of a clean up here. Well, I'm going to add a little bit of flux. It probably would be a better job to change out these spade terminals and then crimp on the capacitor like they did originally. But hopefully soldering will be okay. You can put it down in the comment section if you think otherwise. These spade terminals are massive. If I was using the ones I used when I bought the ones from the Rolls Royce, they weren't as big as this. These do look quite heavy duty. Right, so there's plenty of solder on there. Interestingly, on here it shows a different location to put it, so I don't know if you watched my other Henry video, but I had to change these little things out, and on here they've put the capacitor in between here. I'm wondering if that's because other models have like a high and low switch, and maybe there wouldn't be quite enough room in here to fit it here, because it's still across the live and the neutral on there, but that's happening earlier on this one, while here it's happening a bit later down the circuit after it goes through this the contacts at the top here. Right, so I'm going to solder them up. They're going to be on the switch like so. So I wonder if I was to wrap them round. Let me get the switch and see how wide they need to be. Right, I'm not looking back at my pictures at the moment. I'm just going to put these on here just to get the kind of separation, right? So I'm just going to melt this into the solder, and then I'm going to try to put some more solder on top. Right, that's fully flush against it. Let it cool, then I'm going to add a load more solder on that. Gravity's putting the solder down, you see. Here we go. And that's completely flat on that as well. There we go. So you can see now that the capacitor and the resistor has been soldered onto them there. And I think it's going to have quite a lot of mechanical strength because I went on that side of the crimp terminal where the actual crimp was. So there's going to be plenty of nooks and crannies for the solder to flow into. So I can't see that vibrating loose or anything like that. I think that's going to be just fine. So I'm going to look back at my phone now, find out where these were all connected, put them back the same way. Hopefully Henry should be working again. Right, there we go. So that is back the same as the pictures on the phone, but without the burnt out capacitor. So we're going to put it all back together now, and we'll turn it on live on video to see what it does. I presume Henry's still going to smell because that's all I can smell now in the air around him. So maybe when he's whirring away, he'll still be smelling. So I'll start filming again as we're about to turn him on. Now, if you have a look at that there, that looks like it's routed quite nicely. I think it looks as good, if not better, than what it did beforehand. Here we go, 25-year-old Henry. Is he going to go up in smoke, or is he going to be all right? Come on, come on. Good. No bang. Do you want to do the switch or shall I? Ah, there we go. Fantastic. Excellent. And off. I can still smell the burning from before. One more time. Well, there you go. He's an indestructible little fella, even though he's already been through 2 hoses, a motor, and now a capacitor. And the rewind cable contact springs. There's not much originality left. But 25 years old and very easy and cheap to fix. So that capacitor and resistor was under £5. And with a little bit of solder, you can see how easy it is to fix.
Annoying intermittent fault.
We're going to try to fix up this Anker power bank. This is a Power Core 10,000 because it's supposed to be 10,000 milliamp hours. Now, personally, I like Anker products. I bought this years and years ago, and it has given many years of service, even though it hasn't been used much. It might only come out like once a month. But the final straw was that my daughter asked, can she have some power banks, because she was going away to Creamfields, I think it was, the festival. And I was like, yeah, grab some power banks. I think I grabbed this one here and this one here. And then she got back and said, Dad, this doesn't work. And I remember the last couple of times of using it, it was hit and miss, where my son would say, Dad, it's not working. I'd plug something in and it was working. I think what it is a bad connection. I think it's simply going to be the USB port isn't making contact with the board properly on maybe one of the pins. The problem with it is that it's glued shut, so it's going to be very destructive getting into it, but it doesn't work. So I would rather use a Dremel tool to get into it and glue it shut and make a complete mess of it as long as it works. Worst case scenario, if I damage everything completely, at least I'm going to be able to take out, I presume there's going to be 3 18650s in here, which I will be able to reuse for other projects, because the power bank is good when it works. It's just that the working now has gone. And let me show you this. If I was to plug this into this one, I fixed this in another episode. I think it might have been a job lot sort of video where I did more than one item. If you look here, you can see it's 5 volts. I haven't got anything plugged into draw, but if I move it around the place, that 5 volts isn't, oh, it disappeared there. Okay, but you can see that I can hit that quite a lot and it doesn't disappear. I don't know why it disappeared in that one there. Sometimes this does turn on and off again if it doesn't see anything. Yeah, but now watch if I do the same thing on this one here. So you can see it's working here, but it's going to behave itself now. There, went to 0. Hold on, is it when I put it down? In normal, there you go, in normal use it doesn't work. Do you know what? I'm now thinking it's not a USB problem. Wait 1 minute. 1 second. So you can see that that's not resetting. I think it's going to be a problem maybe where the battery contacts meet the board. There you go. You can see how it's kind of hit and miss. But when I do, oh no. Do you know what? I have to get into it. So he's doing it all the time now. But what's weird is, if you do this and it goes to 0, why doesn't it stay at 0? It comes back in again. Very strange. We're going to take it apart and see what's the matter with it. Now this is going to be very destructive. There's a seam going across here and here. I am going to use Marcel's Vice. Now apparently to get into stuff like this, petrol is supposed to be quite good, but me being a southern softie, IPA is already ruining my fingers, and that's with very little use. So I think petrol would just absolutely destroy them. Also, I don't want the smell of petrol in the house. Because if it could give me a little opening, then I could just tease it all the way along. So you would think this bit would be the easiest bit to break because it's by the button. So it's only glued from here to here. Just trying to shock it open. I think in this instance I'm going to take off this. Oh, I've got through that little bit. I'm scratching it all up now. I did manage to get this in. Oh yes. No way. At this moment in time, I haven't done a huge amount of damage. That's crazy. What? Right, let's try something bigger now. Too weak. Oh my word. No way. I've actually got in there and I don't think I've broken anything on that side. This is very, very good. So now if I can get this in here, I might be able to break the seal along here. Come on. Come on. Unbelievable. Look at that seal. There and there. So apart from these scratches where I slipped, that's going to glue down, I think, perfectly. Amazing. Right now. So, where are you loose? So this is the little button here. Let's zoom in and see if we can see anything. So if it's 10,000 milliamp hours, that means these are going to have to be 3,300-ish each, aren't they? 3,333 each, I presume. Well, that's connected. How about this one? Do you think this has come away from here? There. Do you think that's broken there? No, that seems to be going across here, doesn't it? So where are you loose? I can't see where it's loose. Be careful I don't short anything. Please don't tell me it's the pins here. Imagine if it was just dirt in here. Tell you what we're going to do. Let's just get these top ones and push them down a little bit, just to make sure it's gripping better. In fact, can I not just do this from here? I can do this from here. I'm not going to go all the way, just a little bit. No. Okay, I'm just going to try a different one just in case. Massively confused now. What is it with this one in this one which isn't happy, yet this seems to be happy? I'm wondering now if it's only on worn USBs. I'm wondering, instead of it being a pin problem, it's these contacts here that they need to be pushed up a little bit. Just lift them up a little bit. Got to be careful because I don't want to short it on there, because remember, this is all live. As far as I know, it's just the outer two. No. What is the matter with you? Right, I presume there's a cold solder joint somewhere, so I'm going to have to take this all out. Don't know how easy or hard that's going to be. It's going to be sellotaped in. Let's come in. Oh, very easy. There we go. Right, I'll be able to get that back down, and I can see what the cells are as well. Right, this website is called secondlifestorage.com, and these are the cells here, and they're not lying. Good old Anchor. 3,350 milliamp hours. So if you times that by 3, that is actually 50 milliamp hours over 10,000. So they are telling the truth, which is nice. So yeah, that's what these are here. That's good to know. Now, give up your secrets. Why are you cutting in and out? Is it this thing here? Right, so we've spread that away from here. So now we can do this to the board without doing anything with the batteries, and we know it's good there and it's good there. So let's see now if it's going to cut in and out when I do that. Well, now it's doing well. What's going on? Those pins go right the way through there, so it's not like an SMD, they're through hole. So it'd be unlikely to be there. Is it something to do with the coil? Because that's a heavy item. Oh. Is it the coil? Oh, guys, watch. Coil. When I flick the coil, it's doing it. Why? I tell you what we need to do. We need to get an extension lead and have this the other way, and then I can flick the coil and I might be able to see what's happening. Ta-da! Left over from my eBay selling days. Now I can plug this in here, and we can hopefully see this cutting in and out on here. Right, okay, so now, a bit long. Let's see if we flick the coil. What? Surely it hasn't got anything to do with being upside down. I feel like I'm going around in circles. Every time I flicked the coil, when it was upside down, it did it, didn't it? I can't mimic it now. Ah, hold on a minute. See, it's different. This is now fully in here. So this is suggesting then, if it's only going to happen with this in here, it means it's something to do with the socket. right now it's not working at all. Right, so every time I do the coil, it fails. But is that just the same as me doing that? It doesn't seem to be, does it? Seriously, what's happening? If it was the coil, it should happen no matter what I have plugged in it. No, it's not doing it. Voiceover Vince here. Any ideas? Any guesses what it could be? Found it. Found it, found it, found it, found it, found it. Now, okay. Let me zoom right in and see if you can spot it. So, from here, the pins go through the board. I only found it because of my trusty little eye loop here. Ah, excellent. So have a look where the pins come through the board. So the pins come through here, 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 and here. Does anything look a bit different there? Going a bit more for you. Wait until it stops shaking. Bet you're feeling a bit seasick. Now, if I was to shine a light, possibly, I wonder would that bring up anything different? So I've got a little torch here, a little flashlight. Now, there you go. So if you look at this one, you can see we have a nice kind of volcano meeting the pin. This one, it looks like there's a bit of a shadow down here. So there might be the beginning of a crack joint at the bottom there. That could be the beginning of a crack joint, but look at this. That one is cracked all the way round. Can you see there? And that's why it's making contact, because solder's a little bit soft. But when I whack it, it's just breaking the contact. So if I was to maybe give this a little wiggle, I don't want to obviously short anything, so I've got to be careful because we still have this connected. But can you see here? Like, look, if I look at this one, can you see that? You can see that that's solid, but look at this one. There, you can see it moving. So we'll probably find now that if I was to plug in any lead to it, so maybe the newer leads were not making it happen because, look, I know this is a bit of a stretch, but could it be possible that maybe they're putting, because they're brand new, they might be putting a little bit more pressure on the pin, so they're kind of hitting the solder better, while when you use a lead that's worn a bit, this might be just a fraction of a millimetre, like a 20th of a millimetre lower, which might put the pin under slightly less, less stress, so it's not flexing as much. So if I was to push this in here now, going in, there, so I'm in there now, I think we'll probably be able to see it moving. There you go. You see it wiggling ever so slightly? This one here, just look at that one wiggling. There you go. Look at that. You can see that wiggling now. Brilliant. Right, 100%, no doubt in my mind, I've found the fault. And that is so much more enjoyable than just replacing it, because if I was just to replace it, I wouldn't really know what the problem was. Now I know 100% that that is okay. So I was told when I did this before that I should be removing the old solder because it's, I don't know, it's gone weak or something. Normally I would just reflow that, but I will remove it because I've been told to remove it. So I'm going to add flux here. I'll probably actually reflow all of them. I'm going to add a little bit of leaded solder, then try to suck it off. Do you know what now? Hold on, that just came alive there. Is it because it's using my... No, it wouldn't be using my soldering iron as a ground, would it? No, sorry, it's on a different circuit. What am I on about? Obviously, I'm not gonna short any pins here. I'll try not to. I'm going to struggle here now. And every time I was hitting the coil, I was simply just making this vibrate a bit. Right, that's not working with the solder sucker, so I'm going to try a little bit of solder wick. Come on, wick up. I think that's about the best I'm going to get it. Right, I am just going to put fresh solder in each of them. And let it soak right the way through. There we go. This last one I presume must be ground because it's not wanting to soak in at all. It's wicking all the heat away. There we go. Right, I know it doesn't look as nice as it did before, but it was cracked before. I just want to see if it's gone through to this side here. Yeah, there you go. Can you see that they've kind of met up there nicely now? This was the one. This was the one that was cracked, this one here. So on a power bank, I don't know if it makes any difference about the middle two. I think it might be just the outer two, which is the battery side. I don't know if it needs any data. Not sure. Now I'm just going to get some isopropyl alcohol and clean this up. So that soldering didn't go as well as I thought it would, but it's because it's live and I'm just worried that I don't want to short anything while there's this battery. Batteries will just give out all of their power. You know, if I was to short them, that's why they can go up in flames, because they give out all of their power. So if I accidentally put a big solder blob between two places that I shouldn't, it would be the same as shorting the battery. So that's why I was doing it so carefully. Again, IPA and the lights come on. I'm very worried here. Luckily with this it evaporates off quick. I think I am going to leave it at that. Right, so now if I plug this in again, and if I give it a wiggle, you will now see that they're not wiggling at all. All these here are rock solid. And if we zoom out, I should be able to drop this as much as I want and wiggle it around, and it shouldn't make a difference. We found the fault, 100%. Okay, well let me get this back together. I'm going to use some epoxy to get it back together. So I mix up some Gorilla Glue epoxy. It's a two-part thing that you mix together, and then you have a few minutes to apply it on. So I just put a thin bead absolutely everywhere, all the way around, and then I close two halves together, and then I clamp it shut. And I come back to it in about an hour, just because I'm doing other stuff, but after about 10 minutes or so, it should be fine then to start handling. But I come back after about an hour, and I'll show you it working in the other room. There we have it. It's not as smooth around here as it was originally, but it's not bad. It came apart surprisingly well. Basically, there wasn't any skill on my level there. It was just luck that it came apart so easily. So you can see now that it is charging. Well, happy with that. So now that's not going to be cutting out when my kids use it, which is fantastic. So a nice little product. That in my instance was very easy to fix, just a tiny cold solder joint, but it took me a little while to find it. Again, it shows the importance of visual inspection, but I only seen that when I looked through my eye loop. So you've got to look very closely because it really was just a hairline crack.
Kerching!
Here we have an L&R ultrasonic cleaner. This one is down as a Quantrex 140H. Now, I tried to look this up on Google and I can only see the new equivalent, but the new equivalent is over £500. So I think it's a good ultrasonic cleaner, but clearly this one's got quite a bit of age. Now, it was sent over to me by Mike from My Retro Watches. He got it in a job lot with another ultrasonic cleaner and various other watchmaking equipment. He plugged it in and it had a big puff of smoke and absolutely stunk. Now, in the box that he sent over, I can see this here. So it looks like it's the remains of a capacitor. So I think what's happened is it probably hasn't been used in a long time. The capacitors have dried out, and then when 240 volts was put into it, these went pop and started to smoke everywhere. So I think we will have to replace at least one, maybe more. Let's undo the screws at the bottom, take it out and see if we can work out what we need to replace. Now, I don't want to plug this in because it's 240 volts AC and it might well still have a short on it. Let's just see if we go across these ones here. Do we have a short right now? Interesting, it's flicking between that and that. And it seems it's the same numbers all the time, isn't it? So 178,000 ohms and 349,000 ohms. Isn't that weird? Look at that, over and over again. Let's go that way. Is that the same? Yeah. Ooh, okay. Maybe those caps are trying to charge up or something. Right, so there's no short there between the earth. Or there, but yeah, definitely between there and there. Okay, still not plugging it in. I filled it with some water just to see. I wanted to see if this would drain out, and it does. So with this here, it's just like a little clicky one like that, and then you loosen it up and it allows water to go through. You can tell that this has quite a bit of age to it. In fact, we can take that out. Right, let's undo these ones here. See, that slid a little bit away from the original sticker it was on. Right, now that's going to come out there. Right, so we have two of these transducer type things, and this is supposed to have a heat on it as well. So where is the heat? Is it just, oh, is it this thing here? Yeah, there you go, heat. See the switch here? And it goes to here, and it comes up here, so it must be this corner. So that's the corner that gets heated, just here. And that's the hole that goes down to the drain. Right, okay, now, what have we got going on here? So I can see X2 capacitor here. Looks like we have another 2 capacitors there, but that's not broken. Right, I can see it looks a bit gunky here. So I think this is where the, this here I think is where the 40 capacitor is, just here. Right, let's see if we can undo this. So what do we have? We have a plastic clip here and a plastic clip here. Can we undo them from underneath? No, they're there. Get glasses on. It's better. Right. So there's a massive heatsink here. I need to get underneath here. I think if I undo this screw and this screw, and I've got to undo this bolt here, then hopefully I'll be able to just unclip them from the plastic. No, in fact, I don't need to undo this. I can just take off the whole heatsink here, can't I? So let's just undo this one. Right, so that's going to lift up there. So now I have to undo it from here. Is that going to come out if I do that? Yes, it is. And here. I haven't plugged it in, so hopefully it's all safe to work on. I think it's been unplugged a long time now. There we go. Right, now. So we have a connection here, a connection here, and a connection here and here. Let me take a picture of all that. And mind you, that's soldered onto here, so I'm going to have to undo it. There's quite a few things to undo. I'm going to take plenty of pictures. Well, I think I've got enough pictures there, so now, can I take these off? Yes. Yes. So these haven't got that little tab on that you have to lift. So really I didn't need to take them off there. Let's put those ones back here and I'll take them off the board. Oh, hold on a minute, there's a broken wire. Oh no, oh, I've got to be really careful. That's part of the coil there. So there's a tiny wire, that's just a little bit of insulation over the red coil wire. So I've got to be really careful there. It's got the smell of old electronics. Are we free? That's free there, and now it's these two. Not sure if I took a picture over there. Oh, there we go. Got some more remains of the capacitor. Hopefully we'll be able to get the readings off that. Right, we are free. Wow, look how much that has exploded. I presume originally it was the same size as that one. Look at that. So that would have been the smoke that Mike's seen and smelt. Because it would have shorted across the live and the neutral. Because if we have a look on the inputs, so the inputs come in here. Where do they go off to? Here and here. So I'm thinking that that's here and here, and if you have a look at a capacitor, that's straight over that. So it's shorted straight across the live and the neutral of the AC coming in. Right, let's get rid of all of this. Now, I think it would be wise to replace all of these capacitors here, because if this one blew, this one is going to be off the same age. I can see it's 250 volts, and at the top here is 0.1 microfarad, and it's an X2 capacitor. Now, can we see the remains of this one here? Oh, it's going to be hard to piece together because it's all in bits. Let me get some IPA and give the top a little clean, and then see if we can work out what's what. I know it's an X2 capacitor again, but I don't know what microfarad it should be. These ones here are 4,700 PF, so picofarad, I think. So I'm not going to do any testing on this. I think that it's just age. These often fail in older equipment. I suppose they dry up on the inside and then they just short together. So if I put new ones in and it still doesn't work, we can fault find it further, but it's really common to have these go. Annoying, that's gone, but I think that's 0.22 microfarad. What do you think? So this one is 0. See, it's a comma there, so 0,1. I think that's 0,22. So I think we've been quite lucky there. So if I was to get an X2 capacitor, which is 0.1 microfarad, and one which is 0.22, I think we're going to be okay. But that looks like it's cracked there as well, does it not? Well, I'm going to get my soldering iron on, and I'm going to try to take these all out of circuit. So 1, 2, 3, 4. So while I'm doing that, I'll shout out them My Mate Vince Massive. They are the top level Patreons. And the members this month are Keymon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJVG, Pixie, Russ Melanson, Rickard Bergland, Shamsa Al-Sawadi, Stuart Park, Stephen from the Broken Past over on YouTube, Lee Benz, AJ Computer Services UK, Chris Bayans, Victor B, and Garin Shaw. So a massive thanks to each and every one of you. So these have all come out easy enough, and what I have to do is see if I can order up some new ones. So we have 2 X capacitors and 2 Y capacitors. Let's see what I can find. Now I've been just looking up what capacitors to buy, and I thought to myself, I wonder where the fuse is, because when the capacitors blew, these reefer caps in that quad one, the fuse was built into the connector at the back, like the kettle lead connector. And I had a look here and I couldn't see any fuses. And I've had a look here, and sure enough, it looks like there's a fuse built into here. So I'm pretty sure now, just like the quad one that I did, and just like Mike's last ultrasonic cleaner, I bet you that this fuse has blown here. So let's try to prise it out. There we go. Right, let's see if we have continuity across here. I bet we don't. So we go to continuity. So we should hear a beep. What? Wow, it's working. I wasn't expecting that. Okay. Can't see anywhere a sticker that says what the fuse should be. At the back it just says it must be 250 volts. I can see in here it says 250 volts 10 amps, but that's going to be the connector itself. Just want to see what this is. Right, around here it says 250 volts T1,6A. So 1.6 amps, 250 volts. Well, I'm really surprised that hasn't blown. So we've got the earth here going to the chassis itself. This is going to be the neutral, I think, which is going to be this one. No, that's neutral. And this is going to be live, which is the brown. Okay, so I just have to order up some modern capacitors. So what these capacitors are, it looks like we have 2 X2 capacitors. So they go between the live and the neutral, and they're designed to short circuit when they fail, which it did. And then these little ones here that go from here to here, they're Y capacitors, and they're designed to go between the live and the ground. See, this is the ground here, this one. This one is connected to the chassis here. You see this little green one is connected to the chassis, to that one there. So that's ground. So we're going to have one of the Y capacitors going from live to ground and neutral to ground. I don't know which one's live and neutral, I can't remember now. But yeah, that's it. So the X ones go across live and neutral, here and here, and then the Y ones go between live to ground and neutral to ground. So I'm going to order up some new versions of them. When I say ground there, I should be saying earth, because it's the AC coming in. So one Y capacitor is going between the live and the earth, and the other one's going between the neutral and the earth. I know 99% of you fully know what I mean. I say ground out of habit because most electronics that I work on with the negative, we just say ground. But this is AC coming in, so I should say earth instead. And the reasons we have them is to filter out noise. So it would filter out RF noise and also EMI noise as well. So what I'll have to do is when the new ones arrive, or before that, I'm going to get some isopropyl alcohol. I'm just going to clean all around here, just in case the old capacitors left any residue around the place.
1 week later.
Okay, so a few days later, it might even be a week later. They took quite a while to arrive. My head's a little bit all over the place because I have currently been fasting. Also, I want to show you this watch. I have currently been fasting for, where are we? 11 p.m. I think I had fruit salad. Not yesterday, the day before. So I've gone 24 hours, plus 12 is 36, and now plus another. So I've done 37 hours fasting. All I've had is water, and not really enough water. My lips are dry, so I need to drink some more. And 2 cups of black coffee. There was no sugar, no milk in it. The reason being is that apparently after so many hours, your body has used up its glucose, and then it starts using up the fat reserves. Now, if anybody's seen me, they say, Vince, you're skinny. I am skinny, but I'm like a sort of fat guy stuck in a skinny body. So I know I'm not healthy on the inside. I can feel it. I'm lethargic. I'm lazy, motivation's gone, so I need to do something about it. I've actually been saying this for years. I did videos in the past where I tried to challenge myself. That was many years ago now. And you know what? Since those videos, I've done nothing since. So 2026 is going to change for me. And I'm starting by everybody raves about fasting. If I'm honest with you, I was expecting to wake up today feeling amazing. I don't. I feel actually worse than what I normally feel, and I normally don't feel that good. So yeah, I actually feel a little bit sick, which is weird, and I suppose that's the hunger pains, but I only had hunger for a short period yesterday. Then last night I was fine. I think if I do this video here, I'll take my mind off it and I might go for a walk. I wouldn't mind getting a few more hours of fasting in to see if suddenly I start feeling better, because when I watch videos and look at the comment section, everybody's raving about fasting, so they can't all be lying. So I'm hoping something will kick in sooner or later where I start feeling better. But I've got to be wary because I haven't really got much muscle to lose, so I don't want to get to the stage where my body starts eating up muscle. But anyway, the reason I'm showing you this watch is because Mike sent me this as a thank you for looking at his ultrasonic cleaners. These are Citizen Cosmotrons, and they're old watches. You're talking about 40 plus years old. Didn't he do a great job cleaning this one up? He got it from Japan, and he's given it a service. It's a really interesting watch because it's half battery, half mechanical. So if you're into watches, look them up. He's done a video on working on one of them, and the movement itself, I can't show you the movement because it hasn't got a clear back on it, but the movement is amazing. It's a mechanical watch that's run from a battery, and everything works in reverse. It's really very, very clever. And things like this, I'm going to show you this, I'm going to muck up the time, but this is just insane. Look at this. You're wondering, how do you change the hack mechanism? How do you change the date and time? Because this only pulls up once. And then when you push it in here, sorry, let me do it this way. When you push it in here, you can see it's changing. How do you do the day? Check this out. You have to turn the watch upside down and do it, and now the day changes. How clever is that? So let me just get back to where it was. I love that. I've got to do a how-to video on that on one of my other channels. Another channel called No Waffling, and yet all I do on this channel is waffle. What? Anyway, look, I need to solder in some new capacitors. I spent, I think, £40 on all these capacitors here because I'm sick of waiting for spares all the time. Annoyingly, they're a lot smaller. Well, it's good. You want things to shrink in size because it means you can have smaller power supplies, etc. But they're not going to fill the holes very nicely on this old circuit board here. So you can buy wider capacitors, but these ones will work just as well. It's just that they are now smaller because technology's moved on. I did actually buy some reefer ones as well, but they're paper based, and I think reefer ones, even when they're on the shelf, will fail eventually. Might get another 20-30 years out of it, but I think moisture gets into them, into the paper, and they will fail even when they're not in use, while these other capacitors should hopefully last longer. So I'm putting in slightly more modern replacements, and fingers crossed this will work. I'm not doing any testing on it because it's so common for these reefer caps to fail. If you Google them, you will see that loads of people talk about them. They fail in so many things. Not that it's just a bad design, but remember when these things were made, people probably didn't think they're still going to be in service maybe 30 to 40 years later. It's incredible how quick time goes. But not when you're young, that's only when you get older, and apparently it goes quicker and quicker as you get older. I've got a theory behind that, waffling again. I think if I suddenly moved to Australia, that year would go slow. Then if I was to move to Thailand or Dubai, I think the next year would go slow. I think because we get set in our ways, that time just goes quick. And when you're a kid, you're going to a new school, making new friends, joining a football club, doing this, learning skateboarding. You're always doing something new. While when you're older, days turn into weeks, turn into years where you do the same old, same old. So I think time would go slow if you packed your life full of stuff. Then I think time might start going slow again. But for me, time is whizzing by for me at the moment because I'm doing the same old every single day, which is, apart from fasting, that's something new. Anyway, I'm soldering these capacitors in. Nothing really exciting to show there. Let's get it all back together and then let's turn it on for the first time and let's see what it does. Right, here we go. This should be fun. I haven't turned this on, so I'm going to be doing it live on camera. It might well go bang because obviously I don't know any background about this one here apart from Mike plugged it in and it started smoking badly. But it is very common for these things to fail, so I'm hoping it's only the reefer caps and nothing else. Right, let's fill it with some water. There's no indicator to tell me how much to fill it, but I'm going to put a good amount in there so the energy can go somewhere. There we go. Right, well this annoying thing at the back here is leaking. That's not a good start. Let's squeeze that more. Is that leaking still? No, okay, right, let me just mop up the floor. Not too much leakage. Right, it's cleaned up behind. What it is this pipe's gone hard because it's rubber and it's very old. So Mike's going to have to replace that pipe or block it off completely. Do you really need a pipe? You can just pick this up and turn it upside down. So, but mind you, if it was at your desk, maybe you would like to put this over another smaller pan or something to get the water out. Right, here we go. I am going to plug it in. Let's move the water well out of the way. Please don't go bang. Right, plugging it in now. I'm in. Excellent. It hasn't gone bang so far. So now, does this work? Ooh, that lights up. Nice. Okay. Should we see if it starts ultrasonic cleaning? I presume when we move this, this will come on. Oh, yes. Fantastic. And I can see a few little bubbles already. Right, I'll tell you what we'll do. Let's get some tin foil, put it in there, and see if it makes some holes, and we'll put some heat on as well. Right, I have got some tin foil in it, and I'm going to put some heat on. So I'll get the thermal cam and we'll measure the water now and hopefully afterwards. And let's put it on for 10 minutes. Hopefully by then we might have some damage on that tin foil. Do you know what? Let's be safer. Shall we put it on for 15 and give it a right good test? Why not? Then we'll see if it explodes within 15 minutes. Right, my FLIR cam is flat, but I've just got a power bank plugged into it. Let's see what it's going to show. Right, so right now it's showing 17.8 degrees Celsius. Just going to put my hand in front. Yeah, now it's gone up to 26. So yeah, let's see if it goes up from 17 and then we know it's working. Let me just show you that. I don't know how accurate this is, by the way, but hopefully we'll get something. Hopefully you can see there. Right now it's 18 point, it is climbing. 18.9. Right, let's come back to it then. After 15 minutes, we see if there's any holes in it and also whether or not there's any heat there. There's a new one forming just here. I can see it. Just there. But let's leave it on there for a bit, see if we can visibly see it getting bigger. I tell you what, it stinks. It smells of an old person's house. Since I've turned it on, the smell has got bigger and bigger and bigger. I can now smell it from a good metre away. Yeah, that's getting bigger. I can see bits flaking from the middle. In fact, looking around the place now, elsewhere, I can see little silver flecks. So the foil is breaking down into smaller bits and floating around the place. Excellent, well I think it's working. I'll come back to it. We've got another 6 minutes to go. Let me just quickly explain something that I edited out of the video. It was regarding the heat. At the beginning of the video, I showed the wires going off to something on the corner of the bowl, and I thought that might be some kind of heating element. I don't think it was. I think that might have been some kind of thermal fuse or something, because after that it's going to like a big pad on the side. So I think to heat up the water or whatever liquid you're putting in this ultrasonic cleaner, there's a big pad on one side of it which is applying heat right the way through the liquid in there. Now, I haven't read the instructions, but one thing I think that Mike will need to be careful of is it looks like the heating's working independently off when you move the ultrasonic cleaning dial, which is probably intended because that way then you might want to bring it up to temperature and then just have the ultrasonic cleaning part of it working for 5 minutes. But from what I can tell, I can put this heating on with the green light whether or not the ultrasonic dial is on or off. So I think it works independently of each other. So you'd want to be careful. You want to remember to turn off the heating after use, but it's got a useful green light to remind you that it's on. Well, I've got about 4 minutes left now, and I was wondering if it's getting warm. I don't even need to put the flare cam on. I will to show you, but I can feel it. I can feel it all the way around here, especially this side. This side's warmer than this side here. So I think this might be where, I need to watch back the video, but I think this might be where the element is at the side. So yeah, it's definitely warm, and I suppose that's why it smells more. It's a cross between old person's house and mechanic's garage, an oily sort of smell. So yeah, I suppose it's going to be dust, and maybe the person did, well, even watches, if there was enough of them, they would be oily, wouldn't they? So maybe this all needs a good clean out on the inside. Anyway, I'm not going to put my finger in there because it's bad for you. But I know that that heating thing is working. Let me turn this on and see if it's gone up from the 17 or 18 that it was earlier. See the holes are getting bigger as well. I'll show you that in a minute. 29.6, 30 degrees. There we go. 29.9. Is it hotter over this side? Yeah, 31.3. And over this side, no, about 31 as well. 33, yeah, it's definitely warmer this side. Right, okay, hopefully you can see that there. 33 degrees. And if you have a look here before it turns off. You can see the holes are getting bigger, and if you look really closely just down here, I can see that the silver foil is all kind of dancing along the bottom. Let's see if I can get that in the camera. There you go. So that's all the broken bits of foil. So I'm not sure now what pattern it should have. I can see that the holes are over this side. If you have a look, it's breaking up all down the side here. Oh, dearie me, that scared the life out of me. It's reset at the bottom now. The timer's up. Right, let me take the foil out and I can show you where the damage is. So it was down this side here. And also we've got a little hole forming here and here and here. So I presume what happens is when it breaks through, that's then the weakest spot, so it keeps breaking from there. But it must take quite a lot to break through. And I know I said this in the previous video, but this is quite thick foil. You know, it's good. I'm sure you can buy cheaper, thinner foil. I think my wife gets quite good foil. So yeah, that's it. And I can see in the bottom here that there's loads of bits of foil. So I think it is going to be working okay, because if it wasn't, then it wouldn't destroy the foil, would it? But you can see down at the, hopefully you can see at the bottom there, that there is lots of silvery flecks. So that is it for this video. Not the most interesting. The most interesting part has probably been the watch, to be fair, followed by the fasting, which I'm still doing now. So I've now done, I think I'm up to 40-ish hours. So I'm going to go out for my walk now, and I am then going to feed myself, gorge myself, pig out properly, and all the good work will have gone to waste. Well, there we have it. 3 items done and dusted, and all 3 items appear to be working. So if you enjoyed this video, give it a big thumbs up, and hopefully I will see you again very shortly. Thanks for watching, everyone.